Hi Ron, good morning.
Hi,
How
hi.
are you?
חסר לי כלב.
We started recording, so I switched to English.
What I said was that I'm missing a dog. It's not in the
Pardon?
picture. Your dog is not in the picture.
Because I didn't share my screen yet. I wanted to talk to you as a human being first. First,
No, I'm saying the dog, Gadi,
yeah,
is not
Gadi.
there.
He's not. Yeah, right. He's busy. He went to the bank. He has the arrangement today.
Okay.
Uh, Actually, I just gave him a shower, and he's really angry at me. So last time we were we started
Started
constructing.
programming.
Pardon?
We started programming.
Yes, we started programming the data set. We wanted to construct a data set of x and y, so we can make we can operate a gradient descent on it. You remember what the x and y represented?
Yes.
What's x and what y?
So the X are the images.
X
The
are,
Y is the identification, dog
yes,
or cat.
x are flattened vector of the tensor, which is an image, right? And y,
In tensor, it's three-dimensional because there were colors there. That's what I remember.
exactly, right. And the y, what is the y?
Y is the vectors, 1, 0 or 0, 1.
Yes, the labels are only 1, 0, and 0, 1, but when we'll do a prediction, it will be any probability vector.
Will be blurred. I mean, it's not going to be unique. I mean, it's going to be a probability vector.
Yes, but not only deterministic probabilities, but any probabilities. Yeah. Oh, Gadi is knocking. Just a minute. Oh, God. Okay. So here comes the hero of the day.
Yeah.
Okay, so I'll share the screen and we'll continue, okay? Just a minute. Okay, so this is my screen now.
By the way, I have also a dog here in the background. Do you see it?
Well, it's hard for me to see now. Which dog?
A white dog. Okay, never mind. Yeah, I'm listening.
Okay, so that's where we stopped, right?
Yeah, that was a quarter of an image. Yes.
Exactly, that's where the quarter of an image. So let's before we continue, I need to teach you something else which related to Python and its data structure. Have a look. Let's say A is a list, okay? You do see my screen, right?
I see.
Okay, so this is one, two, but you know, a list in Python doesn't need to be heterogeneous. It can be, it doesn't mean to be
Can be
homogeneous.
heterogeneous.
It can be heterogeneous. So I can put other things here, like a Boolean value here, or maybe a string,
Okay.
or maybe if, sorry, um, um, or, or even another string, right?
Okay.
And also I can put a tuple. You know what a tuple means? It's just like,
Yes, yes. A
yeah.
vector.
Okay. Yeah, you could look at it as an order list of, okay. So, oops, just a minute. So A is now a list, and I want to iterate over this list. I have two ways of doing it. One of them you know, and the other one you don't know. Let's wait for this command to take place. The first command always takes a long time, but now it's fine. If I asking for what's A, okay, so this is A. And if I want to know how many elements are in A, I can ask len of A, like that. Six elements. And what you've seen so far, we can do something like that. For I in range, right? Len of A. Is it clear what I'm doing?
Yes, yes.
Print A, yeah, AI, sorry. And let's type also the type of AI, okay?
He recognizes it himself. Okay, nice. Okay.
Okay, I'm going to run it. Let's see. So 1, 2, just a minute. I'll make more places in the screen. Okay, 1, which is an integer, 2, which is an integer, 2, which is a Boolean value, high 1, which is a string, 1, 2, 3, which is a list, and 2, 3, which is a tuple. Okay? This clear?
Yes, yes, yes.
Ah, great.
He likes the
Now,
word tuple. Okay. Yeah.
let's say I want to show you a different way to iterate over a data structure in Python. I can do something like that. For x in A. This means that A is a data structure and X is an element in A. It's like in other languages, this type of loop will be called for each loop. For each element in A, do something. Print X.
Okay, print will be easy. Okay. But add 1, you cannot.
What did you say?
Printing is easy, but since they are heterogeneous, you cannot do anything else apart from printing, right? Right?
Well, I can print the element, I can print the types. If there were a common function that all of them have, I could operate it if
Yeah,
even
but
if,
you cannot because they're heterogeneous.
so there should be some commonality, yeah.
Yeah. Okay.
Okay. So this is considered a bit cleaner way of doing it because I don't really need the index, right? I used before. It's a nicer code, right?
Yeah, yeah.
Okay, fine. Good. So what do we want to do? We want to construct a list that will look something like that. Let's call it a data set, which will be constructed as follows, right? It will be a list of what? A list of tuples of x, y, right? Like,
in our case, yes, it's so.
Just for simplicity, let's say that x and y are just integer. In our case, it will not be integers, but suppose it was integers, it would have been look like that. The first tuple, the second tuple, the third one, just random numbers.
Don't really understand. So these are the vector x's, the x's that you're now drawing?
Yeah, I wanted to construct a list of x and y. Yeah. X pick y. Because I'm trying, yeah.
2, 3 is x is 2, y is 3. Okay.
Yeah, 2 is x, 3 is y. 1.3.
I thought that y was a vector, wasn't it?
Yeah. It's just an example. It's I want to start with something simple.
Okay.
Yeah. Instead of 2,
okay.
we'll have a whole representation of an image. Instead of 3, we'll have a labeling. Okay. But this is for simplicity. It's just an example. I will run. Okay. Now I can do something like that. For I in range len of data set.
Mhm.
I can.
So the length of the data set is 4 in your case? Okay.
What were you saying?
The length is 4 and 3, sorry.
Yeah.
There are 3 pairs there.
The length is 4, exactly.
3.
Now, just let's play with it. Let's do a data set I. Okay, so now I iterated with the index from 0 to 3. These are the indexes of the 4 elements. And I will
No,
just.
so there are 3 elements. Just or am I confused?
Sorry. Yes, you were right.
Okay.
Only 3 elements, yeah. So from 0 to 2, right. Yeah. And I'm just printing them. Let's run it. Oh, I forgot something. List is not callable. Print. Yeah. It was my mistake. This should be written like this, right? It's the index of a list. It's not a function. You see, he told me that list object is not callable because I treated it as a function. It was my mistake.
Where is the list? It's in the previous.
Data set is a list. Data set is a list.
And data set itself is a list. Okay.
Yeah. So I wanted to print the element.
Yeah, I see that there.
So the bracket I needed to use is the square one. It was my mistake. Okay.
When it's a list, you write a square.
Yeah. If you want to refer to the ith element of a string, you need a square bracket.
It's not a string. Is it a string? I don't see a string. It's a list.
It's a list, yes, a list, sorry. A list. Okay?
Print data set I, and why didn't he like it before?
Before, instead of a square bracket, I used a round bracket as a function. And he told me this is not a function. Let's run it like.
Okay, let's run it and see what it does. Okay.
Makes sense?
Yes, okay.
Suppose I want to separate it to x and y, I could have done something like that. So a data set, data set, it's the ith element is a tuple, right? The ith element of the data set is a tuple. If I say x and y equals to this tuple, it will decompose it into 2 elements. I'm just printing them.
Okay.
Let's run it.
Okay.
Okay.
And if I wrote you just print x, then you would print 2 and so on and so forth, 1 to 1.3 and 2, 3. Okay.
Okay. I want to refer to each x and y. I want in my program, I want to do something with x and y, so it will be convenient. But there is an even cleaner way of doing it. Let's see. For x and y in data set.
And you don't need a round parenthesis around the pair xy, okay?
I don't really need the index. I can do a for each loop. For each pair x and y in data set, print x, let's say y.
Y plus 1.
Okay, so again, that's the cleanest way of doing it. Okay?
Okay.
Okay, after we know that, we can start programming what we really need. So let's do it. I will define a function now, which is, we'll call it something like load data set, for example. def load dataset. Why do I call it like that? Because I want a tool to load all the images from the disk and put them in a list like that with X and Y, okay?
Okay.
I want to take care of my data to construct a very useful and easy to use data structure. You know, sometimes they call people like me a data scientist. You know the term data scientist?
I think so, yes.
I find it insulting, but some people call my profession data scientist
Okay.
because we deal a lot with data. Okay. So what do we need to do? First, we need to read all the images. Let's say we don't have them now. Let's see in our, you see, this is my file system. I don't have the images yet. Let's download them again, okay? In order to download, I will just run what we have written in the last lesson, okay? Let's see. We did it last time. So you remember this wget command? It will just download a file to my system. Have a look. There should be, I will refresh it here. You see, data.zip. Did you notice that Yaakov Ziv just died?
And Lempel as well.
Lempel died last month or something,
Yeah.
and Ziv died like 2 days ago.
Yeah, the lovers, in the Bible it says that the lovers and the lovely or something like that didn't part neither in life nor in death.
Like David and Jonathan?
הנאהבים והנעימים.
Yeah. That's a song for David and Jonathan.
Yes.
Yeah. Okay. So we have the file, but it's still Lempel Ziv, this file. We need to uncompress it. So we unzip it like here. Now, let's see what's, you see, we have a new folder named DS for data set. And here I have all the images again, okay?
Okay.
And also, let's say that's all the inflating. Okay. You remember, okay, I will close this part here. You remember what this command does?
Oh, PIL, I forget what
It's
PIL.
a Python image library.
Okay.
It's just for dealing with JPEG and stuff like that.
Okay.
We used it. This is our, this is the way we used to load an image last time of a cat.
Okay.
I don't need it right now. Do you remember what's import numpy?
Look at the blue thing. There is
Pardon?
DS/ what? DS is a list,
It's a good question. DS is the name of our folder. Have a look, DS.
Folder, yes, okay.
So what I said here, please load the image cat from the folder.
From that folder, okay. Excellent. Okay.
This slash is the notion for subfolder or subfile in Unix, not in Windows. Okay. So do you remember what this stands for? This import numpy?
Import numpy. Oh, I forget.
It was the numerical library that used to handle tensor mainly. Okay, we needed it. So I'm importing again. What else? I think, oh, do you remember these things? Matplotlib, pyplot as PLT. This was for plotting, for drawing images and stuff like that, plotting on the screen. We needed that as well. Okay, I think we're fine now. We can start program. So where were we? We were, by the way, I started writing the whole derivation.
The gradient descent, yes.
Just the computing of the gradient.
Yes.
Look, it's kind of nasty.
Yes, I thought so.
But if you want, I won't say no. You can go over it and check if I did it.
No way. I don't do it in my
It's a
own
lot
papers.
of fun. It's a lot of fun.
Sure.
I must admit that generally during my work, I don't do it. There are libraries that do this tedious work
And,
for me. But
retired
today,
and have now
especially for
the
you,
privilege of not drawing such things. Okay.
Okay, so where were we? We started program low dataset, right? So first we need something to read all the files and to put them in a data structure. Let's do it. We're going to use another library called import. Oh, you see that what happens? Just a minute. It's a problem with the keyboard. Import OS. OS stands for operating systems. It gives me lots of capability to handle the operating system stuff. I needed to read files. I'll show you.
Okay.
I will do something like that. Files equals OS dear list of DS. Any idea what that will do?
Oh, operating system, the
Or maybe
directory list, that it will
I
list
think
your
I should write
directories.
it,
Will list your directories.
Pardon?
It will list your directories.
Yeah, and it will put it as a Python list in the variable files.
Okay.
Let's try. Let's print files and see if it works. You see, all the files are here.
Okay.
So it's worked fine. So let's do it in our code. This is our function load data set. Note that it receives nothing. I don't give it anything, and I expect the whole data structure as a return from this function. Let's start programming. So I will start exactly like I did before. OA, a list dir, and the name of the folder is data structure. Now I will go over all the files and load them. So I will do something like that. For file in files. Did you notice? Did you note the name that I gave? This is a single and this is plural, in order to indicate that this is
the list and file. Yeah.
Yeah, it's just one element. Okay. So image will be Peel is the library for dealing with images. Image is the object inside this library that represents an image. And open is the function that loads an image from the disk. And I need to give it a name of a file. So I'll give it the name file, okay? So for every file in this list, I'm asking to open it, to load it from disk.
Yes.
Okay. Now.
What does the dot signify?
Pardon?
What do the dots signify? Peel dot image, I understand.
Yeah.
But then open, between image and open, these are two distinct entities. I mean, image is a file and open is a command.
It's a good question, Ron. The way we learned Python is kind of, it's not very rigorous way of doing it.
It's very flexible.
Python is also an object-oriented language. And in object-oriented languages, dot indicates something that belongs to. So inside the library Peel, there is a class named image. And image is part of Peel. So image belongs to Peel. And inside the class image, there is a function named open. This dot indicates that open belongs to image. And this dot indicates that image belongs to Peel.
It's very different from Windows, where inside the directory there can be a file, not a command. Okay.
Yes, like that. Okay, now I'm not sure you remember, but last time we loaded a JPEG file, which is using Fourier transforms, and we converted it into a very simple tensor of numbers. And we did it using the library NumPy. So we'll do it again. NumPy has a short name, NP, in our case, and array is the name of the class that represents any n-dimensional array of any number of dimensions, and I will just give it image. So notice that I'm using image both here and here. So this is the, let's document it. Just a minute. This was a load. By the way, this sign, how do you call it in English? Sharp? I don't remember. So let me.
Yeah, sharp. There is a better word, but I don't remember it.
Okay. This indicates the documentation. The computer doesn't pay attention. Load an image from this, and this means convert it into a tensor. Okay? So now image will be just a very simple tensor with numbers, not some, frequencies and stuff like that for like JPEG. It's something very, very explicit, not implicit. Okay, so now we have an image. Now we want X to be what? The image?
The first element, so, but I forget how you say it. So you define the image as the first in the vector, so in the pair? I don't understand.
The data set will be X and Y, X and Y, X and Y, pairs of X and Y. X
So
will represent the image, Y will represent the label, but is it exactly the tensor, or do we want to do something with the tensor?
I want to take the first coordinate, or the first coordinates. I mean,
why is that? Why? Let's remember what's the size of the image? Do you remember? Like the dimension
500 times 500. I don't remember a lot.
It's a lot. Let's see. It should be written here somewhere. Just a minute. Oh, here it is. The shape of an image, 200 by 200 by 3. What's the 3 stands for?
Colors. I remember that. Yes. Okay. 3 colors.
3 colors: RGB, red, green, and blue. And 200 by 200 is the width and height of the image. And I want to flatten it all to a single, right, to not even a matrix, but a vector. But what will be the dimension of the vector that I will flatten it to?
40,000 times 3, 120,000.
120,000, right? It's 400.
Sorry, there are planes here, right? Not here.
What?
There are planes that's going over.
Okay.
I didn't hear. So yeah, now they've gone. Yeah.
A war is starting.
No, it's ordinary.
Okay.
Nothing special.
So 200 by 200 is 40,000, right? And multiplied by 3, it's 120,000, right?
Yes. Okay.
That will be the dimension of the flattened vector, right?
Mm-hmm.
Quite a high dimension. I have hard time picturing this dimension. So here, just a minute. By the way, how much time do we have?
I'm free more or less, but
yeah,
I'll
okay.
get tired.
Okay, fine. Now I would like to flatten the image. I want to convert it from a tensor of 200 by 200 by 3 into one vector, right? But I don't remember how to do it. So we could have Googled it, but we could have do something nicer nowadays. Do you know ChatGPT?
Yes.
So ChatGPT is the new marvel of deep learning, right?
No.
Did you ever use it?
No. I mean, I watched people using it.
Let's use it. Let's use the latest version of it, which is like only a couple of, maybe 1 week's old. It's really nice. So let's ask him a question. I will say, I need a function in
Wow,
NumPy that flattens a tensor, right?
Flattens.
Right,
But
thank you.
Probably get over.
Yeah, he got it right. Okay, I will just ask him.
Better than Smotrich. In NumPy, you can use the reshape function to flatten.
He makes me spoil. He just give me the code, how to do it, and an example. Let's read it together. In NumPy, you can use reshape function.
You'll be very soon fired.
Pardon?
You'll be very soon made redundant with this.
You see, I won't be needed anymore. That's what you're saying?
I think he will not be needed in like a couple of years. Let's see.
That's another conversation. I think I need to embrace this change, and then I will be needed with this. But that's another question.
Okay.
I think that's one of the most impressive things that I've ever seen using deep learning. I think in essence, it's like passing the Turing test, in my opinion.
I mean, this has happened long ago. We don't pass. Humans by now don't pass the Turing test.
Okay, it's a different discussion. In NumPy, you can use reshape function to flatten a tensor multidimensional array. Here is a simple function that takes a NumPy array as input and returns a flattened array. Let's look at its example, okay? Let's look. That's a Python code it just gave it. You see it said Python here. It also lets me to copy it if I want to. Import NumPy as NP, exactly like the convention we use. Def flatten tensor. It gets a tensor. Let's see what it is doing. NP reshape tensor, comma -1. Okay.
What is the -1?
Okay, that's a good question. Why the minus?
I guess because if the length is 100, then you go from 0 to 99. That's one.
Actually, in NumPy, -1 stands for a number that you can deduce Like if you have a matrix and you reshape it, you can give him only one dimension and the other dimension could be deduced because the multiplication must remain the same. But suppose we didn't know all that. Let's look at the code. A tensor, what's that? What did he do here? You understand?
No.
You
All these square
can.
brackets, infinitely many square brackets.
It's just a representation of a tensor. Have a look.
Okay.
It's the dimension of this
I
tensor.
can decipher I now decipher the brackets. I mean,
You understand what he did? He gave us a three-dimensional tensor. And the numbers are 2 at the end. It's 2, 2, 2. It's a tensor of 2, 2, 2. Anyway, he called his own function and flatten it and print it. Let's see if he done decent work. Let's copy it and run it, okay? I'm gonna, by the way, I'm gonna put a link to this notebook we are writing inside the YouTube clip, so everybody can look at the code if interested. Anyway, so now I will paste ChatGPT here. This is the code that ChatGPT gave as an example of flattening a vector. Okay? I just copied here. Okay, Ron?
Yes. No.
Now I'm running it.
Going to give You're
Let's
going
see.
to run it on the data sets of the cats? No.
I copied the example ChatGPT gave me into our notebook, the one we're working on.
This I understand. Now you're going to apply it.
I already ran it, and this is the output here.
What did you run it on? What was the...
I just copied it like this piece of code. I copied it as is and ran it without doing anything.
Okay, let's see what it gives.
And is it working fine or not? I think it is.
No, again, he translated a three-dimensional tensor to a vector. That's what you're saying?
Exactly, that's what he did. Because that's what I asked him to do.
Okay.
So okay, so he convinced me that he knows what he was talking about, and I can use his own technique. But let's ask him what the -1 stands for, okay?
Let's see if he's that clever. Okay.
The big
Is it a
strength
she or
of...
a he, by the way?
Pardon?
GPT is a she or a he?
You know, GPT is an acronym for a generative pre-trained transformer. So you need to know if transformer is a he or she or it. Do you have a do you have an answer for that? Okay. It's an it. I guess it's an it. It's a machine. It's a model. He also that's a mistake of him. It's not C#. It's that's the output. Let's see what he also tells us. Just a minute. In this example, the flattened tensor function takes the tensor as input and uses NP reshape function to reshape it into one-dimensional array. Oh, now he explains.
Oh, yeah, that's precisely what
we don't need to ask. The -1 argument tells NumPy to automatically calculate the size of the new dimension, which results a flattened array. Is it clear now or not?
Yes.
If you want to understand, let's ask him, is...
Not quite, because there are three-dimensional. So you cannot deduce one from another, and you need the two others.
Well, it's 2 by 2 by 2, it's 8. So he deduced 8. Have a look. Here, there is a tensor with 8 numbers, right?
Yes.
The dimension of this tensor is 2 by 2 by 2. And he asked for a single dimension vector, and he asked to deduce its
Okay,
dimension. Yeah, but I want to ask another question. Is there a simpler way of doing it?
Wow.
Another function that I could have used, Ravel. There's a function named Ravel. But I think there is a function named flatten also, so I will ask him about it. I will ignore this answer and ask about flatten. He explained that NP-Ravel function is simpler to use because it directly returns a flattened array without the need for specify a new shape. He really seems to understand what he is talking about. Is the function name flattened as well? Let's put it in like that. What do you think will be the answer?
Yes, of course. It gives you an example. It's very considerate.
I think that's the simplest way of doing it, and the most explicit one. I'm gonna be angry at him now and ask him why he didn't give it to me as my first. Right. This is like the most
I didn't see the
natural
difference, by the way, but
what?
I didn't see the difference between flatten and Ravel, but okay.
What's the difference between this Ravel and the flatten? I didn't understand. Did you?
Yes, I didn't understand. No, I didn't understand the difference.
Let's ask him what's the difference. Yes, and then we'll continue our programming. So, what is
the flatten returns a copy, while Ravel returns a flattened view if possible.
You're still reading?
Yeah, I get to the word contiguous, and then it's.
Yeah, sorry, just a minute. Continuous in memory. He explained the difference.
Yes. Flatten returns a copy. What do you mean returns a copy should return?
Let me read it out loud and we'll talk about it. In this example, the flatten function is called as a method on the input tensor, and it returns a flattened copy of the input array. A copy means another place in memory with the same data. Note that flatten returns a copy of the array, while Ravel returns flattened view if possible. Well, this is kind of a delicate thing that I don't want to get into, i.e. no copy is made if the input array is already continuous in memory. If copy is required, Ravel will create one. So the difference between the two is kind of delicate. I don't want to get into it right now, okay? Let's continue with our code and we'll just use flatten. Just a minute. Can I just erase this? This is what all the answer that we are not going to be using. So here, it should be image flatten. That's it. That's the way ChatGPT told us to do it. Really simple, right? Let's look again at the ChatGPT code. I just use this. I had a tensor and I want to flatten it. That's it. Are we okay?
Yes, okay.
Okay.
This is a very uncommon way to do the function after this, yeah, it's tensor and then dot flatten. Okay.
What is not common? What is after this here?
No, usually I would say image if you want to square the image. Say square of the image. Here it's opposite, but never mind. It's
you expected something like that, right?
flatten image.
Flatten image, right?
Yeah.
But
he's
well,
prerogative.
it has to do with object-oriented programming. Image is an object, and we use its function, which called flatten.
Yeah, and
okay.
It comes after. The name of the function comes after. Okay.
Yeah.
Okay.
We didn't learn Python in a very ordered way. Yeah. Okay, so we have X. What about Y? I want the label.
It belongs to the same array, no? So.
Pardon?
I forget. Y is hidden in the same array of, or no. Well, I don't remember your structure. You have image and then Y. Just write it and then I'll write.
Okay.
I'll understand.
We want data set. That's just a comment. We want data set to be equal to X, sorry, X and Y.
Yeah. So
right? And lots of X and Y. X should be the image. We already have X. What Y should be?
I don't know how you call it. The second
Y is the label, right?
You call it label. Okay.
And it should represent either a dog or a cat. Yes. How do we know if it should be a dog or a cat? By the name of the file, right? That our labeling tells us this is the file of a dog. This is the file of a cat, right? So we'll just use the name of the file in order to know which label to use. So let's see. We'll do something like that. We'll do an if statement. If a file, which is the name of the file, this means only the first 3 letters of the file is a string. File is the name of the file, and comma 3 is the first letter. I will ask whether it's a cat, for example. If it's a cat, I will say that Y equals np dot array. And now I will give a vector of 1 and like that. 1, 0.
No, I don't have to know. This is the 1, 0 there. If it's a cat, then it's an array of. So this is the name of the the vector.
This is my representation of a cat. A vector, a deterministic probability with 1, 0.
Yes. Okay.
Okay. So if it's a dog, so the other case is else. If it's a dog, I will do the same with a different vector, right?
Yeah.
Make sense? Okay, so we have X and Y. Now I want to construct the data structure. So in the beginning, I will just say data set equals an empty list. This is the notion of empty list.
Okay.
And now I know both X and Y here. So I can just add it to the list as a tuple, like
So
that.
now you're listing the outcomes of your learning of your samples. Okay.
I didn't learn anything. I'm just preparing my data.
Yeah. Learn
Yeah.
that this is a dog and this is a cat. Okay.
Yeah. So I will do dataset append. Append is add an element to a
Add an
list.
element. Yes, sure.
And I will add a tuple, X, Y. I already know what X and Y means. Oh, sorry. Just a minute. Sorry about that. I didn't know what happened. Okay. So let's make more place in the script. I want to show you the whole function. This is the whole function. So we started by an empty data set. We listed all the files. We iterate with a loop over all the files. For each file, we loaded it, we flattened it, we computed the label using the name, and then we just added it to the list. So the for list will iterate over all the files, okay? And at the end, data set will be filled with X and Y's. Is it clear or not?
Yes. Are you going to tell me that you're going to use this, you're going to show us all the way to the guess, the
Yes, that's our
learning
paper.
machine? Sorry?
Our purpose is to build a classifier by ourselves.
Really? Ah, to the very end, to the bitter end. Okay.
Yeah, to the very end. And now all I need to do is return what? What should be returned from this function? The data set. Data set contains what I wanted to construct.
Okay.
And I will delete that. Okay? Okay. So now I'm running it, but nothing will happen because I just defined a function. In order for it to run, I need to call this function. Let's do it. I will make a small room, and I will say dataset or dataset ds equals data set. This is calling a function. I want to call this function that I've just written. Now, if everything will work fine, ds will contain all the cloud of the point. Probably it won't run. Why? Probably we have a bug, right? You know, a program.
GPT will correct it, I'm sure.
Pardon?
GPT will correct the bug for sure.
For sure. But you know, a code is guilty unless proved otherwise.
Otherwise, yeah. Okay.
The opposite, let's see. Indeed, that was a bug. Let's correct it. Let's understand what happened. He said that list object is not callable. Yeah, because the name of the function is not dataset. We had a different name for that, load dataset, right? Okay, the name of the function is load dataset. Let's try again. Another bug. Great. He said no such file or directory.
He didn't like s.31. This is probably the first image, right? It's impossible that he ran over all the...
Probably the first. No such file or directory cut. What happened? Let's see. Here I have a list of what happened exactly. First, I I called the function, and inside the function, he said the problem was here. You see this little arrow? When I tried to open the file, he said, now it's internal code of Peel. I'm not interested. I didn't write this. The problem is not here. The problem is here. So what happened? He didn't find the file. Why didn't find the file? I know why he didn't find the file. The name of the file was cat something, but it's inside the directory. I forgot what you asked before. This, I should have added this. The file inside the directory. Remember this ds slash, which means this file is inside the directory, the
what
folder?
Is the plus for? What does the plus signify?
This is a plus between two strings, which means concatenate. So I just constructed the strings, which is ds slash cat blah, blah, blah. Because the full name of the file should be the file in this folder, like we did before. Let's remind you, where was it? When we opened a file before the last time, we did, you remember that?
Yes, I remember that.
You see, I didn't just open cat, I opened ds slash cat. Because the file was inside a folder.
But in what you wrote a minute ago, the ds was between two commas. Now it's just with one.
In Python, it's the same thing. 1 comma or 2, it's the same. You refer to this sign here?
Colon thing. Sorry, I don't remember the name of this sign.
Okay. You're referring to this sign, right?
Yes, yes.
Yeah, in Python you could use either this or this one, but you need to be consistent.
No. What I meant was that, look here. Now it looks right, but before what you wrote was ds as if it's a string or something like that, and then you did slash cat.
Let's see. You refer to what I wrote before, which was this, right? Here.
So it's ds, and then I don't remember the name of this punctuation mark, so it's ds
I
slash.
concatenated two strings. I concatenate the string ds slash and the string file, which is cat blah blah blah.
Okay.
After concatenating it, I could give it to open, and it will find the right file inside the directory, the folder.
Okay.
Let's run it again. So I rerun the definition, and now let's run it. Load data set. Okay, now no bug. Let's ask him some question about ds. So let's ask, what about ds length? Okay, how many elements in this list? What will be the answer? I think 200. Let's see. Because we have 100 dogs and 100 cats.
Okay.
Let's ask about ds in the first element of ds. What is it? Let's ask.
That was the cat that we saw, probably, no?
He said the first element of ds is an array of.
He doesn't tell you everything. Yeah, okay. I don't know what is 49. What is 49?
These numbers are just the colors and the intensity. And what is this?
This is the cat.
Exactly, this is a cat. And let's ask about this is the first element of the tuple, because DS was a tuple. This is the first element, and I will ask about the shape. The shape is the dimension of the tensor, of the image, of the flattened image. What will be the answer of that?
2, 2, 2. Oh no, 2, 2, 3.
An image is
200,
200 by,
203. Yes, okay.
so it should give us 120,000.
Yeah, okay. Flattened. Okay. Yes.
Yeah, flattened.
Yes.
Okay. What about the second element, which is the label here? The second element of the first tuple.
So it's
That
1,
should-
0. Should be 1, 0.
Yeah, but the shape should be 2 on 1, I think.
Let's see.
Because let's see. Because I constructed it as the vertical matrix. Maybe I should have used the vector.
Okay.
Okay. So now
I'm getting a bit tired, so
yeah, fine. That's exactly
it
the
was a
way.
long lesson.
Yeah. It's exactly the place to stop. I just want to emphasize that we are ready to start with the algorithm because we have all the data ready for us. Okay?
Okay. And then we'll try it on Gaudi.
What?
Then we shall try it on Gaudi.
Yes. After we construct a classifier, we'll take a picture of Gaudi and we'll
I hope you will not. We are not
into-
going to offend him.
We'll scale it into 200 and 200, and then we will check if Gaudi is indeed a dog or a cat.
You will have to change his food if it's if you get the wrong answer.
Right, exactly. Okay. So
Okay.
Thank you.
Thank you. Let's see.
Bye-bye.